Alright, good morning and welcome back from fall break. Today we're going to be doing lesson 28 of Module 4. The next couple days we'll be finishing up Module 4 and then we'll be taking our test on Friday. So just make sure you're paying attention to these lessons this week because they will most likely be showing, the kind of questions that we see will most likely be showing up on your test. So by the end of today's lesson you're going to be able to determine the solution to a system of equations through a method called elimination. So you'll know you're successful today when you can use knowledge about least common multiples and kind of change up your system of equations so that you can eliminate one of the variables and find a solution, okay? As always, we're going to go through our lesson with some background skills, some examples, exercises, and then we'll close out and do the exit ticket on your own. Please keep your video on and your mic muted. Please make sure you're showing your thinking and your work. You're participating, you're having appropriate conversations. You're following your job, etc. Okay? As always, keep in mind the question, how does this pertain to your life and why does this matter? Alright, so on this page I'm just going to review some background knowledge that we have learned in the previous lessons. All you need to do is listen and watch. So, as you can see on the left I have a graph and I have two lines that are crossing, which means I have a system of equations. And we write a system of equations with a bracket like that, okay? I do see that my lines cross right here, which means that there is a solution. They have one solution. Those slopes are different, so those lines are eventually going to cross. You can see there's an example up here in purple. If they never crossed, they would have had to be parallel, okay, which is this blue right here. They have the same slope, different y-intercepts, so they never cross. And that means that they have no solution. An infinite solution is when they're pretty much the exact same equation for a line, they overlap. But like I said today, off to the left on this graph, you see that these lines do cross. So what I'm going to do is I'm going to write the system out in our slope-intercept format. Y equals something x plus b. And I'm going to be filling in my x, my m, and my b to create these equations. All right? So I'm going to start with this line right here, and I'm going to find the slope. So to do that, I need to find 2 points that are directly on the crosshairs of this line. So I see one right there, and I see one right there. And to find my m, I'm looking for the rise over the run. So I want to see, going from my left point, which is this one right here, to my right point, how many am I rising? Well, I'm not rising, I'm going down. So I'm going down 1. So that's going to be my rise. And then how many am I going over? How many am I going to the right? 1, 2. So my slope for this first line is -1/2. Okay. And then I'm looking for the y-intercept of this first line. Where does it cross my y-axis? And it hits right there on that 4. So that is the equation for my first line, or that red line that I have indicated. And then I'm going to do the same thing for this blue line as well. I'm going to find 2 points. I see one right here and one right here. Pretty simple and easy. So for this one, again, I'm looking for the rise over the run, and to go from my left point to my right point, I'm going up 1. So my rise is 1, and I'm going over 1. So my run is 1. This simplifies to just equal 1. So this is y equals 1x plus, I'm looking for where it crosses this y-axis, and I see that it crosses right here at point 2. So this is the system of equations for this line. This is just review of what we have done so far. And so far we've learned how to solve a system of equations by graphing. But as you can see on this graph, and I'll zoom in, that point where they intersect does not lie on a crosshair. And what I mean by crosshair is these lines right here that show our grid for our graph. So we can't say, oh, that crosses on 3, 4, because it doesn't. It crosses in the middle of this area right here. So today you're going to be learning a new method for solving system of equations. And the reason for that is because they're not always going to land on crosshairs, and that new method is called elimination, and we're going to get into that in the next slide. Alright, so the new method that we are learning how to solve system of equations with is called elimination. And what that essentially means is we're going to eliminate one of these variables so that we can solve for the other variable. Now, whether you eliminate your x or your y, it is completely up to you. Usually there's one that seems a little bit easier to eliminate. So the first thing you want to do is make sure your equations are lined up in the same format. You want them to follow ax plus by equals c. And I see that my first one, ax plus by equals c. The only thing I need to change here is plus negative. Okay? And the second one, ax plus by equals c. Perfect. So I have everything lined up correctly. And what I'm going to do from there is I'm going to look and see which one of these variables, x or y, would be eliminated if I added these equations together. So if I did 6x plus negative 5y equals 21, and 2x plus positive 5y equals negative 5, and I'm just going to be adding these as if I was adding just a regular equation. So separate it out like this so everything stays the same. And I'm going to see if anything eliminates. So already knowing math in my mind, I can see that this column right here, if I add negative 5y and positive 5y, there's going to be 0 y's left over. So this is going to work out without me having to do anything mathematically. I just have to add it. So I'm going to start with this side. 6x's plus 2x's is 8x's. Keep my plus sign. Negative 5y's plus 5y's is 0 y's. Equals 21 plus negative 5, or 21 take away 5, 21, 20, 19, 18, 17, 16. So now I have this equation, and I have 0 y's. So this actually simplifies to 8x equals 16, because there's no y's there. And now that I have this equation, 8x equals 16, I've eliminated one of my variables, and I can very easily solve for that x. Draw a line through my sign, try to get x by itself, divide by 8, divide by 8, and I get x equals 2. Okay, so I'm almost done with this equation, or with solving this system of equations. I found that x equals 2, but now I have to find what y equals. So I'm going to choose one of these equations that I had originally. It does not matter which one. In my opinion, I always want to choose the one with the smaller numbers. So I'm going to choose this second one right here. And what I'm going to do is I'm going to plug in this x for a 2 and solve for my y. So this becomes 2x plus 5y equals negative 5. And I said, well, I know that x is a 2. This becomes 2 times 2 plus 5y equals negative 5. 2 times 2 is 4. And from there, I'm just going to be solving algebraically, okay? So I'm trying to get the y by itself. Right now, there's a plus 4 beside it, so I'm going to take away that 4. I'm left with 5 y's equal negative 5 and a negative 4, negative 9. From there, I want to divide by 5 on both sides. And I get y equals negative 9 fifths. So I have my x and I have my y. So now I know that my solution to the system of equations is 2 for my x, negative 9 fifths for my y. You could change that to a decimal if you want, but you don't have to for today. Okay? We can always check our solution by plugging those two variables in to any of our equations. So we did it for that first one, but we could, or the second one, we could do it for the first one there. Change the x to a 2, change the y to a negative 9 fifths, and see, will that balance out and equal 21? Okay, and that's what we're going to be doing today. All right, for example number 2, I'm going to go ahead and line these equations up in the same format. So the first one, ax plus by equals c. I'm following the correct format. The second one, ax Well, there's a minus sign, so I'm going to change that to plus negative. Plus by equals 14. Okay? And I'm going to think, which one of these variables do I want to eliminate? Well, if I look at my x's, I have a negative 2x and a positive 4x. If I look at my y's, I have a 7 and a negative 2. Now I'm thinking about my least common multiples. So I have a 2, a 4, a 7, and a negative 2. Well, I guess I have 2 negative 2's. But I'm going to be thinking of my least common multiples, and I know that negative 2 and 4, those ones will cancel out. The only thing I have to do is multiply this negative 2 by 2, and it'll become negative 4, and then they will cancel. So that's what I'm going to do here. So I'm going to take this entire equation and multiply it by 2. Okay, and you'll see that I'm about to rewrite it down below. So 2 times negative 2 is negative 4x. And I did that one. Keep my plus sign. 2 times 7y is 14y. And I did that one. 2 times 5 is 10. Keep my equal sign. And I did that one. So basically what I did is I just took that whole entire first equation and multiplied it by 2, so that when I add these equations together, my x's are going to cancel, and you'll see that right now. So if I add 4x plus negative 4x's, I get 0x's. If I add 14 and a negative 2y, 14y and negative 2y, I get 12y's. If I add 14 and 10, I get 24. Okay? So I just added in an extra step to this one before I had to multiply by least common multiple so that this would happen, so that I would cancel out or eliminate these variables. I know that 0x doesn't mean anything, so this is actually just 12y's equals 24. And that's super easy to solve for. I just divide both sides by 12, and I get y equals 2. Okay, so I know that my y is a 2. I now have to solve for my x. So I want to think, which equation should I plug this into? Well, this first one right here, the numbers are pretty small, so I'll just plug it into that. So I have negative 2x plus 7y equals 5. And I'm going to take my answer, y equals 2, and plug it in for that y. So this becomes negative 2x plus 7 times 2 equals 5. Okay? From there, I'm just going to keep solving. Negative 2x plus, what is 7 times 2? 14 equals 5. And from there, I'm going to draw a line through my sign, solve algebraically for this x. Right now it's being added to 14, so I'm going to take away 14 from both sides. Over here, I'm just left with negative 2x's equals 5. Take away 14. This becomes negative 9. Okay? From there, I want to get the x by itself. Divide by negative 2, divide by negative 2. Over here, it cancels. I'm left with x equals negative 9 divided by negative 2 is the same as saying 9 over 2, because those negatives cancel. So I have my x and I have my y, and I can write my solution as an ordered pair. Nine over 2 for my x, 2 for my y. And I solved through elimination. Again, we can check our work by just taking these two variables, x and y, and plugging them into either of these equations and seeing, does it balance out? Make sure you have this down before we move on to example number 3. All right, example number 3, my first step is to write my equations in standard form. So I have ax, need a plus, so this becomes plus negative 5y equals negative 2x plus by equals c. Second one, I have 3x, I have a minus sign again, so plus negative 3y equals 7. And now I'm going to decide which one of these variables do I want to eliminate. Well, I'm going to look at my x's and see, well, what's the least common multiple of 7 and 3? 3, 6, 9, 12, 15, 18, 21. That's the least common multiple. Okay, well, let's look at these. What's the least common multiple of a 5 and a 3? 3, 6, 9, 12, 15. So which one's going to be easier, smaller to change to? Probably this one right here. So I'm going to have to manipulate both of these equations so that these two numbers become 15s. Okay? Now, to get this first one, this first negative 5y to be a 15, I have to multiply this entire equation by 3. So I'm going to do that right now. Oops. I'm going to multiply that whole entire equation by 3. To get this second equation, for this y to be a 15, I have to multiply it by 5. So this whole equation is going to be multiplied by 5. All right. And the one thing I haven't done yet is I have to decide one of these has to be a negative, one of these has to be a positive. So I'm just going to go ahead and change this to a negative 3 and multiply that entire equation by negative 3. Okay? Here we go. Negative 3 times 7x's is negative 21x's. Keep my plus sign. Negative 3 times negative 5 is 15y's. That's exactly what I wanted. And negative 3 times negative 2 is positive 6. Okay? Second one. 5 times 3 is 15x. 5 times negative 3y's is negative 15y's. And 5 times 7 is 35. So now you'll see that my equations, the y's, they're going to cancel out when I add these up, which is exactly what I needed to do. I needed to eliminate one variable. So starting with negative 21x plus 15x. 15 to 21 is 6, so this is going to be a negative 6x. Keep my plus sign. These cancel. I'm left with 0y equals 35 plus 6 is 41. Okay? From there, I know that this is the same as saying 6x equals 41 because 0y's means there's no y's. And I'm just going to solve for my x. X equals 41 over 6. You could simplify that, turn it into a mixed number, turn it into a decimal. It's up to you. I'm going to turn it into a decimal. So 41 over 6 is the same as 41 divided by 6, which is the same as 6.83 repeating. So I'm just going to leave it as 6.83 repeating. And now that I have my x, I'm going to plug in that x and find my y. Now I think that this equation up here is easier to plug into because the numbers are smaller. So I'm going to change this x to what I actually got for x, which was 6.83. Okay, and from there I'm just going to solve 6.83 repeating times 3 is 20.5. Keep my minus 3y equals 7. Trying to get my y by itself. In order to change anything around in this equation, I got to change this to a plus negative 3y. From there, I'm going to take away this plus 20.5. I'm going to subtract 20.5 for both sides. And I get negative 3y's equals, When I did this in my calculator, I got negative 13.5. I'm going to divide both sides by negative 3. And I get y equals negative 13.5 divided by negative 3 is 4.5. So this is my y. So now I have my x and my y, so the solution to this system of equations is 6.83, repeating for my x, and 4.5 for my y. I know that this is a lot of math, so you guys need to make sure that you are being very meticulous, very detailed, very organized, so as not to make minor mistakes as you go, okay? And we're going to move into our new learning overview and then our exercises. All right, so we now know how to solve a system of equations two different ways, by graphing. This is what we learned all before fall break, and now we have started, we'll work on this tomorrow as well because it's pretty difficult at first to get, is through elimination. When graphing, our solution will show wherever the lines cross, right? But they don't always cross on crosshairs, so that's why we have to use things like elimination. So when eliminating, we eliminate one variable algebraically. The first thing we do, we line up our a, x, our b, y, and our c. Then we decide which variable we're going to eliminate. We choose our least common multiple to eliminate those variables. And then we add up the equations, eliminating the variable, and solve for the remaining one. Okay, so these are the same steps we're going to do each time. We're now going to get into a little bit of practice. Keep in mind, I know that this is going to be very difficult for you at first. It's a lot to grasp, but we will practice and we will get through it, and hopefully by the exit ticket, you will understand what you're doing. All right, I'm going to start you off here. So we have 6x's plus, because plus ax plus by becomes plus negative 7y's equals negative 10. And then our second equation is going to be 3x plus 7y equals negative 8. Looking at these two equations, you don't have to do any manipulating to eliminate a variable. All you have to do is add these up. So go ahead and add these up and find what x equals, because your y's are going to eliminate. So I want you to tell me, what does x equal? Okay? Take a couple minutes to do this. All right, you can see that I've gone through and I've done my math, so I added it up. 6x's plus 3x's is 9x's. Negative 7y's plus 7y's is 0y's. And negative 10 plus negative 8 is negative 18. Okay? From there, I solved algebraically for x. Just divided both sides by 9, and I got x equals negative 2. Please check to make sure that you got this as well. Okay? From there, we're going to plug this into one of our equations up here. So I'm looking at these two equations, and I think that this is the easier one to plug it into because my numbers are a little bit smaller. So that's the one I'm going to have you plug it into right now. So instead of saying 3 times x, I want you to do 3 times negative 2 plus 7y equals negative 8. And I want you to solve for y. So take a couple of moments to do this. Solve for y. What does y equal? All right, go ahead and check your work with my work. So I did 3 times negative 2. I got negative 6. The opposite of plus negative 6 is plus positive 6. So you'll see that I added 6 to both sides. I then got 7y equals negative 2. I divided by my coefficient of 7, and I got y equals negative 2/7. So these are the two coordinates that I have. So our solution to this system of equations is going to be negative 2 for our x and negative 2/7 for our y. You could have also turned that into a decimal if you wanted. Negative 2 divided by 7 is the same as, I think that this is negative 0.286 or something like that, rounds off. So that's if you turn it into a decimal. But check your work with my work, and we're going to move on to exercise number 2. All right, exercise number 2, the first thing we need to do is make sure our equations are written in ax plus by equals c form. Ax plus by equals c, standard form. So the first one I have x, there's just a 1 there, ax plus, this becomes plus negative 4y equals 7. The second one becomes 5x plus 9y. Everything's set up correctly already. Okay, from here, this is where it gets a little bit tricky. We need to decide which one of these is going to be easier to eliminate, our x's or our y's. And what we need to do is find the least common multiple. So my multiples of 1 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. My multiples of 5 are 5, 10, 15, 20, 25, 30, etc. So the least common multiple between those is a 5. So I would only really have to manipulate this top equation because the bottom equation already has the least common multiple. For my y's, the least common multiple of a negative 4 and a 9, or 4 and a 9. Well, let's think about 4, 8, 12, 16, nope, 20, nope, 24, nope, 28, nope. It's just going to be 9 times 4, which is 36. So this is a much bigger number. So in my opinion, the easier variables to eliminate are the 5 and the 1, which is our x, okay? So that's what I'm going to have you do. Now, to do that, this first equation has to become something x that can cancel out with our positive 5x's. So this needs to become a negative 5. So to make that a negative 5, you have to multiply the entire equation by negative 5. So that's what I'm going to have you do right now. Distribute that negative 5 to manipulate that first equation. Take a couple minutes to do that. All right, go ahead and check your work with my work. Negative 5 and a 1 is negative 5x. Negative 5 and a negative 4 is 20y's. And negative 5 and 7 is negative 35. So this whole first equation, I've changed. Now I'm just going to line it up with my second equation and do my elimination. So I had 5x plus 9y equals 6. So now I want you to do your elimination here. And your x's are going to eliminate, so I want you to solve for y. So tell me at the bottom, what does y equal? Okay, take a couple minutes to do this. All right, when I did my math, I got 0x's plus 29y's equals negative 29. When I divided by my coefficient, I got y equals negative 1. So I'm going to plug that into one of my equations. I think that this equation up top is the easier one. So x plus negative 4y equals 7. And I'm going to be changing that y to a negative 1 to solve for my x. Okay? So please do your math there and solve for your x. Tell me, what does x equal? Because we already found out what y equals. Do your math, and then we'll check it together in about 30 seconds. All right, I got that x equals 3 when I did my math. Check your math with my math. Make sure you got the same answer. And so our solution to the system of equations is x is a 3, y is a negative 1. Okay, we got one more exercise before we get into our exit ticket. All right, this is the last exercise. I want to make sure that these are following the correct format. Ax plus by equals c. The first one I just had to change opposite, the negative sign. And we have 3x plus 5y equals 1. So these are set up correctly now. And I want to decide which variable do I want to eliminate. So if I look at my x's, what's the least common multiple of 2 and 3? 6. If I look at my y's, what's the least common multiple of 3 and 5? 15. So which is going to be the easier one to change and eliminate? My x's. Okay? That means that those both have to change to a 6. So to change this first equation to a 6x, I'm going to have to multiply by 3. because if I multiply by 3, it'll change that 2x to a 6x. My second one, I'm going to have to multiply by 2 because it'll change my 3x to a 6x. Okay, so take a second, change both of these equations by multiplying, and tell me what your two new equations are going to be. But before we do that, we have to make one of our x's negative. It doesn't matter which one you do. I'm just going to say, let's do this top one, negative 3. So it turns all those into negatives, okay? Check your work with my work in just a second. All right, you can see that I have distributed my coefficients that were on the outside, my negative 3 and my 2. And I've changed my equations up, and they should follow this format now. Negative 6x plus 9y equals 15, and 6x plus 10x equals 2. That is supposed to be a 10y. 10y equals 2. When I add these up, I'm going to eliminate my x's. So this becomes 0x plus 19y equals 17. So now I have 19y equals 17. Divide by my coefficient of 19. And I get y equals 17/19. You could turn that into a decimal if you want. 17 divided by 19 in your calculator comes out to the decimal of 0.89. I'm just going to keep it as that. Okay, so I have my y. We're now going to plug that in to find our x. It's up to you which one you choose to plug this into. I'm going to plug it into this second equation because there's no negatives there. So this becomes 3x plus 5 times 0.89 equals 1. Go ahead and take your time, solve that out real quick, and tell me, what does x equal? All right, I've gone ahead and I did my math out. You can check your math with my math if you need to. But we just solved for that x variable, and when I did all my math out, I used a decimal. I got negative 1.15 for my x. So the solution to this system is negative 1.15 for my x and 0.89 for my y. Okay, and that is the last exercise we've done. We're going to close out the lesson and then we'll get into our exit ticket real quick. So just to close out the lesson, we can solve systems of equations by a process called elimination. So we want to make sure that our variables are lined up. And we just add to eliminate one of our variables. Now, throughout this lesson, we've been following the same format, ax plus by equals c. You'll notice that on these two questions, they're in different formats. So you're able to use different formats if you'd like. So I'm going to set these up for you so that you can solve by eliminating. Okay, so for this first one, I just want you to add this up. This becomes a plus negative. And tell me what you get for your y when they cancel. One thing I do want you to know is that there is a 1 in front of both of these y's. So I'm going to start you off. 1y plus 1y is 2y. 3x plus negative 3x is 0x. And negative 5 plus 7 is 2. So from there, I want you to solve for x. Okay. After you have x, plug in and solve for y. And then I want you to write your solution as x, y, and tell me what you got for your solution for number 1, okay? For number 2, I'm going to change this up and rewrite it so that it follows the same format really quickly. So this first one is going to be 4x plus 1y equals 6. Then we have 2x plus negative 1y equals 11. So again here, You do not have to manipulate it at all. I just want you to add it up. Eliminate a variable. So eliminate your y. Solve for x. Plug it in. Solve for y. And then tell me what's your solution in x, y format. Okay? Take your time, show your work. If you're confused, go back and rewatch some examples and exercises, and use your calculator. Be organized and be thorough. Okay? After this, please do your lesson reflection.